Alright, so here we are processing WIP. First of all, let's go and make a very simple processing sketch. Maybe what we'll do is we'll actually build this sketch into the OO example that I want us to kind of work on in the class today. So here we go, very simple sketch, void setup. Okay. Let's do something really nice here. Let's go. Hello, kid. Okay, so there's a very simple processing sketch. I'm going to save this. Find the folder. It's quite important that you remember what folder you saved it in. So I had it in Documents, Courses, Processing WIP, and now I'm going to name this sketch. What are you doing today? We're going to do classes, right? So let's call this classes. So there's my Git sketch, and it's in this folder now called classes. Okay. So it's nothing terribly exciting so far. Alright, now what I want to do is I want to put this project under Git version control. And I want to be able to track changes and do commits and everything into this project. So first of all, if I type pwd there, it shows me that I'm in the folder Courses Processing WIP. So the first thing I want to do is cd into the folder I just created, which is called classes. Alright? If you type ls, ls means what? Does anybody remember? It will list all of the files in a directory, okay? So it's the equivalent if you had the DOS prompt up here, you type dir, but on the bash shell it's ls. So ls shows me that there's my file classes.pde and there's my file sketch.properties inside the folder classes. Alright, very first Git command. This should go into your text file or your notebook or whatever you use to keep track of your Git commands. First Git command is git space init. So if you have your computer there and your bash shell open, if you have the GitHub coins, just fire up a DOS prompt and you can do it from a DOS prompt as well. But if you have the Git for Windows installed, type git space init inside that folder and press enter. So the first thing that happens is Git will tell you it's initialized an empty Git repository in that folder there. And this is quite an important concept. So if we minimize this window here, go back into the classes folder that I just created, you'll see that this mysterious file with no name and just an extension .git has been created. Now if you don't see that file, it's because you don't have hidden files, right? See hidden files there? You uncheck that, you'll see that it will disappear. Remember I talked to you about file name extensions. Very important that you have that checked if you're on Windows 8 or Windows 10 or whatever, and also you want to be able to see hidden items. So that by default has got the hidden flag set, so you don't normally see it. Alright, but anyway, you turn on the hidden flag and you'll see the file. The interesting thing is this .git folder here has got lots of files and lots of folders inside here. Pretty much we never ever deal with this folder directly. We always deal with it via the git command line, and it will manipulate files and folders inside there. An interesting thing though, if you find that you've screwed up your Git repository, you have your files, you want to just delete the connection between the file system and the remote Git server, all you do is delete the .git folder, then any connection between those files and any connection to Git is gone. So that folder is basically everything that Git needs to keep track of all of your history of files and the Git connections and to remote servers and things like that. Is that okay with everybody? So deleting the Git folder means you're basically deleting the history of that and any Git connection with that particular folder. Okay, first command, git init. Alright, so we've initialized an empty Git repository. Next thing I might want to do is, well, what should we do now? Why don't we set up a connection between this Git repository on my local computer that I've just created and a repository on GitHub, so I can synchronize the two. So let's go up onto GitHub in my web browser here, github.com. If you don't have an account on GitHub, you need to create an account on GitHub first of all. So I click over here to repositories, and I want to create a new repository, and this is going to be the remote server that I'm going to synchronize my local files with, right? So First of all, you give the repository a name. It doesn't really matter what name you give it here. However, when you clone the Git repository, the Git repository folder name will be whatever the repository name is. And as you might know, processing expects the main sketch in your program to have the same name as the folder that it's in. So I suggest you make this the same name as the folder. Okay? So if my folder is called classes, my sketch is called classes, then this should be probably called classes as well. So, yeah, then you can give it a description. I suggest you put something in here, because if you put something in this description section here, it will create a file called a readme.md file, and it will put the contents in here. So let's say an example of classes in processing. Okay, and then public. The private one will be unchecked unless you've signed up for that Git academic thing. So make it public. Down here we have initialize this repository with the README. I would always make sure that that's checked. The README is kind of an important thing. When you go onto a Git repository, it will show you the contents of the README. So if somebody goes onto your repository, the README basically is going to tell them, you know, what the repository is about. So it's quite important that you initialize it. This step here is absolutely critical, okay? Is to add what's called a git ignore file. So the git ignore file, there are lots of files that we don't want Git to keep track of. We only want stuff like our PDE files, our processing sketches. But any files that processing makes, for example, if I try to do a build of my processing sketch so that other people can use it without having processing installed, I don't want those files to go into the Git repository. You know, if this was an ordinary Java project, stuff like class files, things like that, we don't want to go into the Git repository. Anyway, Git ignore files, you can edit them yourself, but Git is also kind of set up for Git ignore files for different frameworks and languages. So the Git ignore file you want to add is for processing. So make sure you choose add Git ignore for processing. If you're doing a C# or a Unity project, you'll see that there's lots of different options there. Next of all, you can add a license. So I always add the MIT license. You can choose to add a license or not. But if you add an MIT license, then that gives other people permission to use your code, but they have to give you an attribution. They have to say, I got this particular line from Rhino. And that's all I care about when I'm putting code up on my Git repository. I'm not going to sell it. If people use it, I would just like to get credit for it. So you put the MIT license up there. To be honest with you, I've thousands of lines of code up there. You know, my projects get forked and stuff like that. And lots of people have used them for projects. Students have used them for projects, but you know, Microsoft are not queuing up at my door trying to buy my code off me or anything like that. So it's perfectly okay to just allow people to use your code if they want, right? And then you choose create repository. So there we go, that's my Git repository. And you'll see that that's the contents of my readme.md file. That's the file that when I edited the description, that's the file that got made. So there's my Git repository. So now what you need to do is create a connection between this Git repository on the GitHub server and your local Git repository that we created on our local file system. So how I do that is come up here to where you see the URL. So I just take the URL and Control-C that, and then come back over to here, and I now need to create the link between this Git repository and that URL. So you type git space remote add origin, okay, and then you paste in the URL that you copied and pasted. On this laptop, and by the way, from the bash shell, if you're on Windows 10, you can paste by pressing Shift and insert. So shift and insert as opposed to Control-V. I'll just write that up. Shift plus insert will do a paste for you. On the Mac you can press Command CMD and C and CMD and V to do copy and paste. On Windows, I don't know why you can't do Control-C and Control-V from here. You have to do shift and insert to do a paste. Alright, so press enter. So I just want to explain what this command is doing, right? So first of all, obviously Git runs the Git program. Git remote basically says this is something to do with a remote, and a remote in Git is something that you might want to synchronize your Git repository with. Add obviously means add a remote. Origin in Git terms is what's called an alias. So you can have lots of remotes. Okay, Git is distributed, so you don't just have to Most times you'll just have one server, but you can have lots of Git servers that you're synchronizing with. But origin is what's called an alias, and it's an alias for this URL. So lots of Git commands, I'll type origin, and what Git does is then it just uses this as whenever you type origin. One other quite important thing about origin, a lot of Git commands don't require you to specify what server you're connecting to, and if you don't specify a server, by default, Git will use origin. Okay, so it's important that you set up an origin remote at least, because it's the sort of default server that you want to connect with. Alright, so that's created the link between the local Git repository and the Git repository on the server. Next thing we want to do is do our first synchronization. So what we're going to do is we're going to take the files on the remote Git server, because Git has created a couple of files for us, the git ignore file, the license file, and the readme file. And now I want to synchronize those with my local Git repository. So to do the sync for the very first time, what I'm doing is doing a one-way sync, taking the files from the server, synchronizing them with my local machine. So you type git space pull origin master. So you only have to type origin master the first time. Git pull means take the files from the remote server and pull them so that they're in the local server. Origin basically says this is where you get it from, and master says pull them into the master branch of the repository. So press enter, and Git will go up to the server, get the files, copy them locally, do any merging that needs to be done, but obviously there won't be any merging at this time. And then it says, okay, I'm creating a new branch called the master branch. So there we go. So now if I type ls, I'll notice that I have a few new files created, right? So first of all, there's classes.pde and sketch.properties, but there's also the license file and the readme.md file. And where's the, wondering why the, what you call it, the, if I type ls space minus a, no, ls space minus a, where is the, yeah, there's git ignore, okay. So the git ignore file is also there. I don't know if that's a hidden file or why is it not showing up. Anyway, there's the files on the file system. You know, these are the ones that GitHub created for me. If I right-click on the git ignore file, you can see what it actually looks like, right? And all it is just a list of files that you want to leave out of Git. So Git will just ignore these files. So anything with applet, Linux and stuff like that, you can put stuff like, you know, wildcard, so star.class, for example. You know, that means leave out any file with a .class or a .class extension gets left out of that. Any files like this you want to get left out of Git, you can add them to the git ignore file. Anyway, for processing sketches, pretty much the default one will do the job. Have a look at the license file. Here's the license file. Okay, so that's just the MIT license, the standard MIT license. And then let's take a look at the readme.md file. MD files are really amazing files. I don't know, like, it's such an obvious and simple idea. These are called markdown files. Have you come across markdown? So you've done HTML, which is called markup, and you've come across, I don't know, Word files and things like that, which are obviously binary files with lots of stuff in them. Markdowns are very simple text files. And I write all my courses now in Markdown. You know, Markdown, I'll give you another class on Markdown, but basically a single hash symbol like that means this makes it into a heading 1, and then you just put your text. If you want to embed code inside a Markdown file, you can use this symbol here, and then say it's Java. I'll give you some Markdown examples another day. It's not really today's class, but just to show you can actually embed code inside Markdown, and then you'll be interested to see what it looks like, you know, when it gets rendered. So say it's int I equals 100. It doesn't get compiled or anything like that, but if I save this file and upload it to the Git repository, you'll see how this ends up really beautifully formatted. So this is why, I don't know, I think it's a nice way of marking up text or marking down text so that it looks really nice, and it's very simple. You don't need Word or anything to use it. It's a text file. Anyway, there we go. I have now taken my files from the remote Git server and synchronized them locally. Next thing we might want to do is make a commit. Okay, so I want to take all my files that I have on my local file system and commit them to the Git repository. So to do that, there's a number of stages. First of all, git space add dot. Okay, space dot. So git space add means add all of the files in this folder recursively to a staging area ready to be committed. So it goes into this temporary area. It's not quite committed yet, but it's ready to be committed. If you have deleted files, then deleted files will not get added to the commit by default. If you want to get your deleted files add, you have to put add minus all. Otherwise your deleted files will remain. Okay, so git space add will do 90% of the time, but if you've deleted files, you put the minus all in there. So git add dot. Now we're ready to do our commit. You can do git add dot lots of times, right? They don't get committed at this stage, they just get ready for committed into what's called the staging area. And then finally you type git commit. When you type git commit, you should always put a message beside it. So a message basically is just a piece of text which gets associated with that particular commit. So git commit space minus m, and then double quotes, and then you just put some piece of text. Like that. Git commit minus m initial version. And there we go. I have now made my first commit. So the commit is just made locally at this stage, and I haven't actually synchronized this commit with the remote server. So to synchronize it with the remote server, git push. Oh, sorry. Damn. Okay, let's do the long way. Git push minus set upstream origin master. Sometimes you have to do that. I don't know why it didn't figure that out automatically, nevertheless. Most of the times you just type git push, it knows you're committing to the master branch, and it just commits to the master branch. Alright? So that's my first push done. Now if I jump back over here and hit reload, I'll see that now I have my classes.pde file and my sketch.properties file. So those files that I made locally have now been pushed to the server, and you'll see that there's the comment, initial version, right? And it's a minute ago, and so on. Okay, time to make a change to one of these files and see the history of the file, right? Let's jump back into processing here. And now I'm going to save this file. I'm going to edit the file slightly. Okay, and I'm going to change it to say, hello Brian. Let's do something else here. Let's draw a circle. Alright, so now I've done some changes to the file, save the file, and now let's go through that workflow again. The steps required from now on are a little bit simpler. You know, most of that stuff is just required to set up the repository. Now what we do is just git add dot, git commit minus m, say new version, and then git push. There is a way to do the git add dot and git commit in one. I can't remember what the syntax for that command is, but you can look it up, or I'll look it up at the break. So now I have two snapshots of my project. I've now made two commits. A couple of things that you can do. At this point, you can look back at see the history of the branch. So you type git log. And git log shows you the entire history of the branch, right? So there's initial commit, which was something that the Git server made automatically for me. Then there's my initial version. This is the commit I made. And then there's the other commit that I made prior to that, or just a minute ago, okay? So that's the history of my current branch. If you jump over here to the GitHub client, you can do some really cool things. So if I reload that page there again, it now says, look, there's 3 commits on this repository. There's 1 branch on this repository. You can select one of the files. For example, this file that I made, classes.pde, there it is. You can say, show me the history of that file. And there we go. There's the 2 versions of it. So you can even do, what's the one here? Is it if I just click on it? Yeah, there you go. It will show you what was added at each version of the, what was added at each commit. So do I click on this one here? Yeah, there you go. So it's showing me the previous version of the file. That's the previous version of the file. It's saying this is the previous commit, and then this is your current commit. So it's showing you the differences between the files. Is that okay with everybody? Most of the time that will do you. That's all the Git commands you need to know. Git, but if you want to kind of move on to do the next level of Git, you can do branching and you can look back and get previous versions of files and stuff. So let's do some of that, right? This is maybe slightly more advanced. First thing maybe we'll do is I'll just show you how to go back to a previous version of a file, right? And unfortunately it's a rather long-winded process, but this is how you do it, okay? See these numbers here? These are 40-digit numbers, and each one of those 40-digit numbers corresponds to a commit, and is the unique identifier for that commit. So if I want to say go back to this commit version here, then I need to basically copy this 40-digit number. So here's the 40-digit number. If I want to go back to this old version of the project, I copy that 40-digit number, and you type git space checkout, and then you paste in that 40-digit number, and press enter. And now Git will tell you you are now in detached head state. You can look around. First thing then we're going to do, and we'll build this up from first principles, right? And maybe while you guys are working on this, I'll see if I can get the game to work. Very first thing we'll do is go and create a new processing sketch, or use the one you just created. And I want you to write some code to draw the ship. The ship looks like this, okay? Now, don't worry about objects or classes or methods or anything at this stage. We'll just, first of all, let's write the code to draw this ship, okay? So, just use 4 lines and parameterize your ship. So in other words, I want to be able to parameterize it and say x and y, they're the coordinates I want it to be drawn at. The next thing I want to parameterize is I want to be able to say how big it is, and let's call that a variable w. And the x and y should be the center point of the ship. Okay? So just write some code, very simplest processing sketch, declare some variables x, y, and w, and draw that little ship. Alright, that's the first step that we'll do. And I'll try and get the game to work. Cool. Okay, so this is pretty straightforward. Let's declare a couple of variables here. Float x and y, and let's give these some initial values. And let's make one other variable called w, which is going to be the width. And let's draw our lines. Okay, so keeping in mind that I want x and y to be the center point of this thing here, then I need to work out the coordinates of this here, and I can see that this is going to be over half the width. Okay, so hopefully you figure that bit out there. So it makes sense maybe to make one other variable called half w, and say that's going to be equals to w multiplied by 0.5f. It's just a handy thing to have that calculated in advance, because we need it to calculate pretty much all of the coordinates that we need, right? So the first line is going to be over x minus half w, and then y plus half w, and then we're going to go over x and then y minus half. I'm not too worried if your code looks different to this, okay? This is just my way of doing it. You might have come up with your own way as well. And then that's going to be that line there. Okay, then we're going to draw a line from here to here. So this will be over x and then y minus half w. And then we're going to go over x plus half w. And then we can do y plus half w. So there's our 2 lines. And then let's draw the center lines. Line x, comma, y. Hang on, let's think about this for a second. This should be x plus half w. And y plus half w. And then the center is going to be x and y, because that's where we want the center to be. And then we draw our last line, which will be x minus half w and y plus half w, and then x and y. So I don't care if you came up with a slightly different way of doing it, but I think that kind of makes sense because I want the x and y to be the center point of it. So I want everything else to be, you know, that's half the width and that's half the width over there and that's half the height. So kind of just calculating everything relative to x and y. So let's just make sure that that works. And there we go. There's our spaceship. Okay. So the whole principle behind this concept of object-oriented programming is that, well, the first thing that we need to learn is that we can look at something like a simple game like this, and everything that we see on the screen, which is like an object in our game, we can make a software object out of that object that we see on the screen. So, how does that work, right? So the first thing that you do, I suggest you do, is create a new tab for every new software object you want to create in your program. It's good practice, it's a good habit to get into the practice of doing this, because when we do Java in the second semester, you'll realize that for every class that you make a separate file. Alright, or for every object that you make. So let's call this ship. So here's my ship tab, and this now becomes a separate PDE file, a separate processing file. Now I want to encapsulate that drawing code into this new thing that I'm making, this idea of this ship object, this software thing that I'm making. And so the code looks at some new syntax, right? So first of all, you type class, and then give your class a name. You've probably done some of this stuff with Richard. Okay? So this is now the ship class, right? A class in programming is described as being a template for an object. And this is going to tell us what every object is going to have and what every object on our screen is going to do. That's what this class thing does. So the things that it has, what are they? They're basically just variables. So what variables does this ship have? Well, it has three variables that we've decided. It has an x and y, and it also has another variable called w. Okay, so yeah, why don't we give it the half w as well? Good idea, yeah, because we will use that repeatedly. You know, log half w. So these are the things that every ship now has. Every ship has got an x and y coordinate, and every ship has got a w, and every ship has got a half w variable that it holds. The next thing that we learn about classes and objects is that we want to sometimes give these default values. Alright, the default values are typically allocated inside a special method on this object, and this special method is called a constructor. So a constructor is a method that gets called whenever the object is created. And the constructor has a few characteristics. The first thing about a constructor is, I'm going to make some notes here, this is the constructor. And then the first thing we say is that it has no return type. Okay? So it's not void anything, or int anything, or ship anything. There's no return type for the constructor method. The next thing about the constructor is its name is always the same name as the class. Okay, and we can give these guys default values now. So you can go x equals width divided by 2. Okay, that makes sense, right? Because we want it to be basically, or let's do it, but now I prefer multiplied by 0.5f, alright? And the y is going to be equals to the height multiplied by 0.5f, and these are default values. Half w will say is going to, sorry, w then, let's give it the value of 50, and then half w is going to be equals to w multiplied by 0.5f. Okay, so this is what my ship is starting to look like, right? I now have a thing called a ship. I know that the ship is going to have an x, y, a w, and a half w. And I've now made my first method on the ship, which is the method that will get called whenever the ship gets created. So, these up here, these things here, are called fields. They are now fields of the ship class. They're special types of variables. They're not global variables. They're not local variables. They are now fields of the ship class. And they're, if you like, things that the ship owns. Every ship owns an x and y, a w, and a height. A half w. So the next thing we're going to make on this ship is what's called a method. Right? And a method is a thing that a ship can do. So So for this little example of the ship, this ship is only going to be able to do two things. It can move and it can draw. Alright, so let's put in those methods. Let's give them kind of decent names. Let's call it update instead of move. And in update, we're going to put some code to move the ship. We'll put that in a minute. I'll get you guys to write that. Let's put in the code to draw the ship. So to disambiguate this draw from the draw method that's built into processing, we'll call it something different. Let's call it render. And in here, we'll refactor our code. So we'll take classes over here, and we'll take all of this lovely code that we have, and I'm going to delete it from here. Control X, and delete all of these guys, because we no longer need them here. Instead, the ship is going to know how to draw itself, and we can put that code into the render method. Alright. Cool. So that's my little template for a ship. Initially, it's obviously very simple. All I'm doing here is I'm just drawing the ship. We've got the constructor, and we have some methods to draw the ship. Alright, so that's the render method. So, over here in my main sketch, of course, if you run this sketch now, what will happen? Nothing. Nothing will happen, because I'm not calling any methods. My sketch is now empty, apart from this new thing that I've created, which is a ship. So, now what we want to do is we want to create what's called an instance of the ship, right? So this is how you could do that. You go ship. So previously, don't forget, we would have done stuff like int I, float f, and so on. So when I do ship like this, this is the type, and this is a variable. So it's the same as going int I, but the type is now this composite thing that I've just created called a ship class, right? A few interesting and very important points of information. The class name always should start with an uppercase. Okay, so when I'm making a ship class, and I make a note here as well, because it's really important that you get into this habit straight away. The class name should start with an uppercase. So your ship class and your ship file should be called ship with an uppercase, and your class should be called ship like this. So the class name always starts with an uppercase. The instance, when I make ship lowercase, it's called an instance of the ship class. Okay, so you'll often hear programming books and YouTube videos and Khan Academy talking about instances of classes. Ship is an instance of class now. Okay, ship is an instance of the ship class. So little lowercase ship is an instance of ship with an uppercase. The thing about Java is, when I do ship like this, what it does is it basically says ship lowercase is an instance of ship with an uppercase, but it doesn't actually allocate any memory to hold those variables at this stage. So in order to actually allocate some memory, you have to then go ship equals new ship, like that. And if you forget to do that, what will happen is you'll get what's called a null pointer exception. I'll show you what one of those looks like in a minute. But unless you actually go at some point something equals new something, the same as with arrays. Remember we used to get null pointer exceptions with arrays, but we just declared the array but forgot to allocate it. You'll get the same thing here. Unless you go ship equals new ship, you won't get any object being created. And then you go ship dot render. So the dot in this case here means call the method on this object. Call the method render on the ship object. So now hopefully when I run this I should have the same thing more or less, but now this is the object-oriented approach. This is the OO way of doing the same problem. So I always want to run through that again. I know you might have done this with Richard, but this is, like I say, it's the most important thing you're going to learn this year. So I just want to make sure everybody's clear about the concepts here. So first of all, whenever we're making a new thing in programming, we typically put it into a new tab. The name of the tab should be the name of the thing that we're making, and it should start with an uppercase character. This code here, class ship, means we are now making this template for objects that I might want to create later, and this template is called a ship. Right? So it's a ship with an uppercase S. This method here is a special method called a constructor. It has no return type. Its name is always the same as the class, and it's the method that gets called when the object gets created. And then these guys here are just called methods. Alright, so these are methods on the ship class. The interesting thing is you can't call render anymore. Like I can't just over here just call render. Like that. That doesn't work anymore. That's because you need a ship to render itself. And what we're doing is we're calling the render method on the ship object, right? So, the next thing then we might want to do is to add some code to move the ship around a little bit. Alright, so do you guys know how to do that yourselves? Yeah, take some keyboard input and have the ship move around. Can you do that? Either using the mouse. So the simple way to do it is just if key open square brackets like this, and then you just say what key you're looking for, and that will tell you if that particular key is pressed. Alright, so that tells you if the space key is pressed. Similarly, you can go something like, you know, the W key or whatever, like that. Okay. I think that's the way you do it. Let me just double check to make sure that works. No. Actually, sorry, there's two steps. Sorry, my apologies. This is the way you do it, right? If key pressed, and then you go if key is equals to the space key. Yeah, that's the way you do it. That'll tell you if the space key is pressed, right? That will work for all of the keys. Let's make the ship move up, down, left, and right with WASD keys. Okay, try that. Try and put that code in yourselves, right? Okay, we're almost done for today, so let's just finish this off. So, yeah, if key equals W, what do I want to do? I want to do something like Y minus minus, subtract something from the Y. If the key equals S, I want to add something to the Y. Key equals W, and then if I press A, I want to subtract something from the X. And if I press D, I want to add something to the X. Alright, so run the sketch now. Nothing. Why nothing? Ben knows. Because you have to remember to call the update method. I put the code in now, but I haven't actually called that method. Ship.update, ship.render is a good sequence to use.
You also need the background?
What's that? Oh yeah, probably need the background code as well, yeah. See this stroke 2.5, I would personally think the best place to put that is inside the ship render method. The reason why is because the ship render method should be, you know, it's this kind of encapsulation idea. Anything the ship needs to draw itself, it should just draw itself. It shouldn't need external things, you know? Here we go. Okay, so we've made a class, we've made an instance of the class, we put methods on the class, we put fields on the class, we made a constructor for it. I wonder is there one last thing we should do today, or how are we doing for time? Just finished. We've got about 4 minutes left. I think we'll probably leave it at that for today, right?